Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of x plus 2 to the power of x is equal to 2. So now the first thing I'm going to do is, on my left-hand side, I'm going to factor out 2 to the power of x. So now I have 2 to the power of x times, 2 to the power of x divided by 2 to the power of x, that's equal to 1. So I have 2 to the power of x times 1 plus 1 is equal to 2. Now, if I simplify what's in the parentheses, I get 2 to the power of x times 1 plus 1 is 2 is equal to 2. Now, what I'm going to do is I'm going to multiply these two. So 2 here, this is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, this is the same thing as a to the power of m plus n. So in this case, m is equal to x and n is equal to 1. So this is going to equal 2 to the power of x plus 1 is equal to 2. And 2 is the same thing as 2 to the power of 1. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, x plus 1 is equal to 1. Now, I'm going to subtract 1 on both sides. These two cancel out. I'm left with x is equal to 1 minus 1, which is 0. Now, another method of doing this, so I have 2 to the power of x plus 2 to the power of x is equal to 2, and I'm going to do the same thing at the start. I'm going to factor out 2 to the power of x, so I have 2 to the power of x times 1 plus 1 is equal to 2. Now, if I simplify this in parentheses, I got 2 to the power of x times 2 is equal to 2. Now, instead of multiplying these two, I'm actually going to divide both sides by 2. So then these two cancel out, and left with 2 to the power of x is equal to 2 to the power divided by 2, which is 1. Now, anything to the power of 0 is actually equal to 1. So I'm going to rewrite 1 as 2 to the power of 0. So now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x is equal to 0. Now to check, I have 2 to the power of x plus 2 to the power of x is equal to 2. Now, I know that x is equal to 0, so now I have 2 to the power of 0 plus 2 to the power of 0 is equal to 2. Now, anything to the power of 0 is equal to 1, so now I have 1 plus 1 is equal to 2. And 1 plus 1 is equal to 2, so I have 2 is equal to 2. And because this is right, our solution is right. Alright, so I have x to the power of 3 minus 27 is equal to 0. Now, I'm trying to find the value of x here. So, for my solution, I first start with x to the power of 3 minus 27 is equal to 0. Now, 27, this is the same thing as 3 to the power of 3. So now if I substitute in 3 to the power of 3 for 27, I get x to the power of 3 minus 3 to the power of 3 is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, a is equal to x and b is equal to 3. So now I have x minus 3 times x squared plus 3x plus 3 squared. That's equal to x minus 3 times x squared plus 3x plus 3 squared, which is 9. And remember, this is equal to 0. So now this gives me two equations. I have x minus 3 is equal to 0, and I also have x squared plus 3x plus 9 is equal to 0. So for x minus 3 equals 0, all I have to do is add 3 on both sides. These two cancel out, and I'm left with x is equal to 3. So this is one solution. Now for x squared plus 3x plus 9 equals 0, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is equal to 1, b is equal to 3, and c is equal to 9. So now I have x is equal to negative b, so negative 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is 1, times c, which is 9, all over 2a, so 2 times 1. So now I have x equal to negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 is 4, 4 times 9 is 36, all over 2 times 1, which is 2. And now I have x equal to negative 3 plus or minus the square root of 9 minus 36. That's equal to negative 27 over 2. And now negative 27, the square root of negative 27, I can rewrite as the square root of 27 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1, this is actually equal to the imaginary number I. So now, if I replace I with the square root of 27, or sorry, the square root of negative 1, I get negative 3 plus or minus the square root of 27, I over 2. So these are two other solutions to this problem. So now my first solution, this is 3. My second solution, this is negative 3 plus the square root of 27i over 2. And my third solution is negative 3 minus the square root of 27i over 2. So these are my three solutions to this problem. Alright, so I have 2 to the power of x is equal to 5. Now I want to find the value of x. So for my solution, I first start with 2 to the power of x is equal to 5. Now I'm actually going to take the log on both sides. So now I have log 2 to the power of x is equal to log 5. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times log a. And this property is actually so important because, as you can see, right now we have 2 to the power of x is equal to 5. And x here, this is an exponent. And it's going to be really hard to find the value of x without it being a normal term because x is actually going to be a decimal here. 2 to the power of 1, this is equal to 2, and 2 to the power of 2, this is equal to 4, 2 to the power of 3, this is equal to 8. So 5 is somewhere between 4 and 8, so the value of x is going to be somewhere in between 2 and 3, and it's going to be a decimal. So now by using this property, I can move x to the front, and then now I can find the real value of x, the exact value I mean. So I had log 2 to the power of x is equal to log 5. Now by using this property, I can move x to the front, so now I have x times log 2 is equal to log 5. Now, if I divide both sides by log 2, these two cancel out, and I am left with x is equal to log 5 over log 2. Now, the value of log 5, this is equal to 0.6990. And the value of log 2, this is equal to 0.301. So now I have x is equal to 0.6990 over 0.301. And if I divide these two, I get x is equal to 2.32. So this is my answer.